Okay, welcome back to another physical sciences lecture. We're doing some displacement versus time examples in this one. In the last lecture, we looked at just some simple displacement versus time graphs. And in this one here, we have an object which moves for 8 seconds, as shown below. The initial movement is easterly. So the positive direction is east and the negative direction is west. Now, this one's slightly different because we have a bit of a change in direction of the motion. It's indicated by the two lines. Okay, so what is the object's displacement at time 3 seconds? So at 3, it's here. This is the 3, and then what you want to do is grab a ruler, and we'll try and rule this in. I have a bit of trouble sometimes with my using a ruler on the screen, but there we go. It's roughly straight, so you want to get it straight as possible. It's a bit easier on pen and paper, and I estimate that to be around 7. I usually estimate that around 7, so just above it would be 7.5. If you're in a test and you said it was 6, then it's pretty close, so I probably wouldn't mark you down for that. But we'll say that 7 meters. 7 meters, and that's in east because it's positive. 7 meters east. At time 7 seconds, again we go to 7 seconds, which is here. So this is 5, 6, 7. And we do the same thing. Let's draw a line across. Okay, and so that one, again, I'm going to say that's -7. So -7 meters east, and just remember that is equal to a positive 7 meters west. Okay. So calculate the object's velocity at time 1 second. So if you remember, the way to calculate velocity is by looking at the gradient of the curve. So what you can do is you can use any point along this curve, so the gradient remains the same on a straight line. So I'm going to actually use this rise. This is our rise here. That's going to be our rise, and then along here is going to be our run. Okay, but it should be the same as if you use this point, the actual point at 1 second as well. But just to show that it's the same across the whole thing, I want to do the whole line. So I've got V equals rise over run, which in this case I said was 10 over 2, which is equal to 5 meters per second. That's in an easterly direction because it's positive. Okay, and if you use the actual point, this is 5 over 1, which is the same as 5. Okay, but just to show that it's the same, I just wanted to point that out. At 5 seconds, 5 seconds here. Okay, so I'm actually going to use, because this straight line is all the way along here, I'm going to use this point here as our rise, and this is going to be our run. So we're going from a positive 10 to 0. So V equals rise over run, which is equal to -10 this time because it's going from positive 10 to 0 over 3. And that is equal to 3.33 or minus 3.3 meters per second. And that's in an easterly direction, which is equal to a positive 3.33 meters per second west. So it's easterly here because it's a negative east. Negative east equals positive west. The third velocity here is 7 seconds, and just notice that at this point here, okay, it's on the same line as this point here, it's 5, so it's going to have the same velocity, okay? So it's also going to be V is equal to 3.33 meters per second west, same as part 2. So what was the object's total displacement during the 8 seconds? Well, with a displacement versus time graph, it's quite easy to see what the total displacement is. So this is at 8 seconds, and we can see that that corresponds with a -10. So -10 meters, so S equals -10 meters east, which is equal to 10 meters west. Okay. What was the total distance moved during the 8 seconds? Okay, well, distance, slightly harder to work out. So we went up, so from 0 to 2 seconds, we went 10 meters, and then we went back 10 meters here. So we're now gone 20 meters, and then we go again a further 10 meters. So all up, we've gone, that's moved down. Let's see if I can move this back. I think it wants to be there. Okay, so distance is equal to 10. Ooh, and now what's happened? So 10 meters plus 20 meters. So the second line was 20 meters, which is equal to 30 meters all up. Okay. Computer's kind of funny. Find the object's average velocity. So remember that v equals s over t. So it's going to be negative 10 if we're keeping with our convention of positive and negative. Negative 10 divided by 8 seconds, which is equal to negative 1.25 meters per second. And that's in easterly direction, which is equal to a positive 1.25 meters per second west. So that's the average velocity. Remember, speed equals distance over time. So that's going to be equal to 30. Ooh, it's not very nice, 3. Let me fix that up. 30 divided by 8. And 30 divided by 8, let me just quickly put that in my calculator. 30 divided by 8 is equal to 3.75 meters per second. And remember, speed is a scalar, so it does not need direction. That means it does not equal direction. So it doesn't need direction, so it's just 3.75 meters per second. And I think that's the end of that example. Okay, so we'll look at velocity versus time graphs next.